Welcome you all for engineering chemistry classes. Today we'll discuss on metal finishing, which belongs to second module. First, let us discuss or let us know the definition of metal finishing. So metal finishing is all about the modification of the surface properties. That means the process which carried out in order to modify the surface properties of a metal by deposition of layer of another metal or polymer or by the formation of oxide layer is all about metal finishing. So metal finishing is defined as the process carried out in order to modify the surface properties of a metal by deposition of a layer of another metal polymer or by formation of oxide layer is called as metal finishing. So there are some technological importance of metal finishing, which includes increase corrosion resistance, improved wear resistance, impart electrical and thermal conducting surfaces, and imparting thermal resistance, imparting hardness, and to offer the surface thermal or optical reflectivity, and so on. So these are some technological importance of metal finishing, which is very important question to be asked in examination. So read carefully. So let us discuss about electroplating. So electroplating is a process of electrolytic deposition. Electrolytic deposition is nothing but the deposition of a metal or an alloy or a polymer is going to be done by passing an electricity is what we call it as electrolytic deposition. So that includes, as I already told, that is the deposition of metal, alloy or composite on the base metal by means of electrolysis is what we call it as electroplating. So there are three factors which are governing the electrolysis. Those are like polarization, decomposition potential, and overvoltage. So let us discuss about the polarization. So polarization is all about departure of the electrode potential, that is either increase or decrease in the electrode potential due to inadequate supply of a species from bulk of the solution. So I mean to say that there is an increase or decrease in the electrode potential due to inadequate supply of species from the bulk of the solution to the electrode surface, which is normally we call it as polarization, that is concentration polarization, which I can explain with the help of a Nernst equation, that is E is equal to E naught plus 0.0591 divided by N into log of metal ion concentration, where E is the electrode potential, E naught is the standard electrode potential, and Mn plus, that is concentration of Mn plus, is nothing but metal ion concentration. And in presence of electric current, metal ion concentration decreases, of course. So whatever the metal ions near the vicinity, or sorry, near and vicinity are both same, so near the electrode are get converted to or undergoing a reduction from metal ion to metal atom, and that metal atom is getting deposited on the other electrode or the cathode. So there is a decrease in the metal ion concentration at the vicinity of the electrode. So there is a difference in the concentration of ions near the electrode to the bulk of the solution, which develops a potential. So there is a decrease or increase in the electrode potential because of difference in the concentration of ions from near the electrode to the bulk of the solution, which itself is called as concentration polarization. Okay, so the concentration polarization is depending upon like the nature of the electrode, that is size and shape, concentration of electrolyte and its conductance, that also affects, and temperature, products formed at electrode, and we can overcome the concentration polarization by stirring. The rate of stirring is also varies, and to decrease the polarization effect, the electrode surface must be large and low concentration of electrolyte must be formed in the electrolytic bath, and that too with the high conductance. So this is all about concentration polarization. So let us go for the discussion of a decomposition potential. So decomposition potential is explained or is defined as a minimum excess voltage which is required to have a continuous electrolysis process is called as decomposition potential. So I repeat, the minimum excess voltage is required to have a continuous electrolysis of an electrolyte is called decomposition potential. So which is we measured using electrolytic cell. So this is all electrolytic cell. So we have like this is a source and a thin uniform wire, that is AB, and we have an emitter here, and on the wire AB we have a slider, that is we call it as a C in the explanation, and here these are the two electrodes, that is a platinum electrode and this is a electrolytic bath, and this is the voltmeter. So this is all about the equipments which we have used in electrolytic cell. So next we go for the explanation with respect to electrolytic cell. So the cell consists of two platinum electrode immersed in the electrolyte. The voltage is varied by moving a contact C, as I said, on wire AB, that is a thin uniform wire AB. We have to slide over there. Accordingly, there will be a change in the current passing through the cell. And whatever current passing through the cell is measured with the help of ammeter. When dilute solutions of acid or base is taken in the cell at a low voltage, that is 1.7 volt, there will be no reaction, there will be no evolution of oxygen and hydrogen at a respective electrodes. But the secondary cell formed produces back EMF. That is because why there is no reaction, because there is a formation of a secondary cell, because that platinum electrode are get converted to active hydrogen and oxygen electrode, because of which the secondary cell is formed, which is going to produce a back EMF. So that back EMF is going to oppose the applied EMF. When we increase the voltage more than 1.7, there is a sudden evolution of hydrogen and oxygen gases takes place at the respective electrode. So that means there is abrupt increase in current also observed at this point, which we can see in the graph. This is a determination of decomposition potential. We can see here. This is a graph where we are plotting the graph, the current versus the applied voltage, and we can see in the initial there will be no reaction, there will be no evolution of hydrogen and oxygen at a respective electrode, because the platinum electrode are get converted to active hydrogen and oxygen electrode. See this line, whatever is there, there is no reaction. As and when we apply voltage more than 7, there is an abrupt increase in the current. That means there is the evolution of oxygen and hydrogen at a respective electrode is taking place. So whatever the intersection of these two straight lines will give what? Decomposition potential. That itself we can mathematically we can calculate with respect to this E back EMF is equal to E cathode minus E anode. This is how we are going to determine the decomposition potential. So next to this we'll go for the decomposition potential values enables us to continuous electrolysis or to progress the continuous electrolysis, and also used in separation of metal ion when the mixture of electrolysis is supposed to be, or ions were there in the solution. So next we go for quickly over voltage. The excess voltage that has to be applied above the theoretical decomposition potential to start the continuous electrolysis is called over voltage. That means we have to apply little or not little, like we have to apply excess voltage then actual is nothing but theoretical voltage, then only there will be an electrolysis is going to be continuous. The difference what we can see, that is actual the decomposition or electrolysis is taking place and actual theoretical value where it is supposed to take place the electrolysis, whatever difference is there, that we call it as a over voltage that I have given here. And ED is equal to E cathode minus E anode plus the H, that is what again the factor influence. I will give an example here. See, the reversible electrode potential of oxygen gas with the smooth platinum electrode surface under standard condition is actual theoretical 1.23. It is supposed to take place, but it is not so. as and when we apply 1.68 volt, then there is a reaction is going to takes place, and whatever difference, that is 1.68 minus 1.23, that is 0.45 volt, is what we call it as over voltage. So this is how we have to explain. The knowledge of over voltage is used in the electrolysis for deposition of metal, and higher the electrode potential, cations will be easily discharged at the electrode surface. And electroplating process. So the plating process is carried out by pre-treating object followed by electrolysis. So now we go for the practical aspects with respect to electroplating. So before going for electroplating, we have to treat or pre-treat the object, or where we want to have a deposition, that should be pre-treated. So that steps are like, first is removal of organic impurities. So removal of organic impurities like grease and oil material, whichever is there on the object, that are supposed to be removed using an organic solvents. For example, isopropyl alcohol and a trichloroethylene, or 1-chloroethane and perchloroethylene. We can use these organic solvents to remove the oil or the organic impurities present on the surface. Then after this organic removal of organic impurities, we are going for pickling or removal of oxide scale. So this is going to be done by treating it with a dilute H2SO4, that is sulfuric acid, where we are going to remove the rust particle, or we can say a dust particle, whichever is there, that are going to be removed out. So then polishing. So polishing, even we can go for either mechanical polishing or by electrolytic polishing. We can go for both the things, like we can call it as electro polishing. So where the electro polishing is given to get a polished surface, right? So mechanical polishing involves grinding or scrubbing using this abrasion wheels or some sandpaper. These all things are going to be used to polish the surface of the metal. After that, we have to go for rinsing and drying. Rinsing and drying is nothing but, so rinsing within a lot of water, lot quantity of water, and after washing, then we go for drying. It should be air dry. There should not be any moisture on the surface. Then we have to go for electrolysis. So this is all about the pre-treatment, or before going for electroplating, the metal or the object should be undergo these all steps. Now we go for electroplating of chromium, which is very important. In electroplating of chromium, we have two purpose. One is for decorative chromium, for decorative items, where the thickness is very less, right? And another is like a hard chromium. So hard chromium is where the thickness is very large, say about 0.25 to 250 micrometer, so which is used purely for an engineering applications or industry applications. So for both the compositions we will discuss now. So here I will list out, I just given a bath composition here. This should be maintained before going for electroplating up of chromium. See here. So electrolyte must be like a chromic acid. We normally call it as chromic acid bath, in which we take chromic acid and H2SO4 in 100:1 proportions. And operating temperature with respect to decorative is 45 to 60 degrees centigrade, and with respect to hard 43 to 66 degrees centigrade. There is no much difference with our temperature. You have to concentrate more on current density, where in decorative, where the thickness is very less, we are maintaining a 100 to 200 milliampere per centimeter square. Even we can say about the feet per meter square. So this is what we have to maintain. So current density is all about the distribution of a current across the electrode. That is what we call it as current density. And in see here, hard chromium, we can see the current density is like 250 into 430 milliampere per centimeter square. And even you come with the current efficiency 8 to 12, and with respect to hard 10 to 15. pH is same on both the side, and you please concentrate more on anode. So we can't use the chromium metal as anode here, right? So in place of the same metal, we are using an insoluble anode, that is lead and tin, or lead antimony coated with lead oxide or stainless steel. Say about 6% of lead antimony is going to be used, or normally alloy is going to be used as an anode here. Okay, if we use a chromium, then we can't maintain a chromium ion concentration in the electroplating bath properly. So we can't use this chromium metal as an anode here. and the cathode is an object to be plated, that should be pre-treated. So where we want to have a deposition, that is going to be taken as cathode. And application with respect to decorative, it is for decorative and corrosion resistance finish. And for hard chromium, it is for engineering applications or industry applications. So this is the bath composition of the electroplating up of chromium. So next we go for the reactions which are involved in the electroplating up of chromium. You can see here the reaction, you need to practice the reactions here. Let me tell you, that is a sulfuric acid here, whatever we are using here, sulfuric acid, that is going to act as a catalyst here, which is going to bring out the converting, which is going to convert the chromium 6 to chromium 3 by complex anodic reactions. You can see the chromium oxidation state of chromium with respect to here is 6 in this case. When it is undergoing, or it is going to be converted from 6 to 3 by the complex sulfuric acid by undergoing a complex anodic reaction. And to maintain concentration of chromium 3 ions, insoluble anodes are like as I already told and used, and a lead oxide which is going to oxidize chromium 3 to chromium 6 and control the concentration of chromium 3 ions in the electroplating bath. So these are the reactions, and the cathode reactions is here, a very simple reaction where the thing is, and normally chromium metal passivates strongly in acidic sulfate medium, and it gives chromium 3 ions on a dissolution in presence of large chromium 3 ions in block. If the chromium 3 ions are more in large or large in concentration, then there is a possibility of black deposition to be observed. And a difference in efficiency of anode and cathode, that is 120%, as I already told. And the application with respect to this, like an decorative and this industry applications and all those things were there, you please go through it. And now we go for electroless plating. So electroless plating is a method of depositing metal or alloy over a substrate by controlled reduction of metal ions by a suitable reducing agent without electrical energy. So that means same thing, deposition of metal or alloy over a substrate by what? By controlled reduction reaction. Reduction is nothing but the metal ion are converted to metal atom. That is going to be done by controlled chemical reactions. That is by using reducing agent. That means we are not using electricity here. That's why it is called as electroless plating. So electroless plating is all about the process which includes the deposition of metal or alloy over a substrate using or undergoing controlled reduction reaction. Reduction reaction without using the electricity is called as electroless plating. And a reducing agent we are using, that is involving in the conversion of metal ions to metal atom, and which is going to be get plated. And here one more important thing, this electroless plating is also called as autocatalytic plating. So why we call it as autocatalytic plating? Because the cathode which we are using, that should be catalytical active surface. If it is not so, we have to make it active with the catalyst. So we have supposed to use it, and that is why that is initiating the reduction reaction. Once the reduction reaction is initiated, and that is going to be continuous. So this is why we call it as autocatalytic plating. Okay, now we go for composition of electroless plating bath. Okay, what are the requirement for a electroless plating bath? A typical electroless plating bath consists the soluble electroactive metal salt, reducing agent, either hypophosphite, formaldehyde and hydrazine, that depend upon the metal which we are going to deposit, and complexing agent, either we can use citrate, tartrate and succinate, which is going to improve the quality of the plating, and accelerant which is going to increase the rate of plating. Those are like we can use in a succinate and a glycinate and a fluoride. These are all used as a accelerant. And a stabilizer, which is going to prevent the instability of the bath. So we can use the lead, calcium, thorium, thiourea, these are all used. And buffer, so this buffer is used to maintain a constant pH. So these are the components, compositions of the electrolysis plating. So here the advantages, and I just listed out it, you please go through it. And here electrolysis plating up of copper, this is very important with respect to exam point. Okay, so before going for electrolysis plating up of copper, we have to undergo you have sorry we have to undergo the pre-treatment and activation of surface. As I already told, if the cathode is not of catalytical active, that should be made catalytical active by treating it with the stannous chloride and then in palladium chloride. So this is how. Let's discuss about a plating bath, that is electrolysis plating up of copper, that is a bath composition. So we are using a copper sulfate of a 12 gram per liter, 12 gram per liter, and a reducing agent we are using a formaldehyde, that is 8 gram per liter. Then a buffer solution we are using here sodium hydroxide, that is 15 gram per liter, and clay salt of 14 gram per liter. Complexing agent we are using EDTA, that is 20 gram per liter. Complexing agent is to maintain or to balance the metal ion concentration in the electroplating bath, that is very important. And pH is 11 and temperature is 25 degrees centigrade. So here the reactions are here, you can just go through it. Ultimately the overall reactions, the aromas are here and there, you please make it out. So here the printed circuit board, the applications are printed circuit boards used in printed circuit board and plating on non-conductors and plating through hole connections. So through hole connection is like this, I have explained here. See here, consider a fiber sheet. This is in a fiber sheet. The edges, whatever the not edges, that is the top and the bottom, are supposed to be copper coated. And next, what we are supposed to do, we have to have a hole across, and we have to activate that hole. Then we have to deposit a copper in that hole. Then we can have a through hole connections. Through hole connection is nothing but we are going to have the electrical contacts on both the sides through that hole. This is how we can use both the sides for a circuit. So this is one advantage of this electrolysis plating up of copper. So please go through the reactions are very important, practice it. Okay, so as you know, cathode is like copper 2 plus ion, which is absorbs an electron and copper is going to form. Where here formaldehyde, and we are using we are maintaining a pH 11, so obviously we are using sodium hydroxide, hydroxyl ions, and which is going to give these products, and overall reaction is copper 2 plus ion, formaldehyde, and this is all those things. You please go through it. Composition of bath. Okay, now we'll go for acid nickel bath. This is one more addition with that, electrolysis plating up of nickel. So this is the bath composition with respect to acid nickel bath and alkaline nickel bath. So coating solution is almost same, but the weight or the quantity what we are using, there is a slight difference. And reducing agent is both the same. And buffer, here we are using the sodium acetate. Since it is an acidic, we have to maintain an acidic, that is pH 4 we are maintaining 4.5, and here in alkaline we are maintaining pH 8 to 10. So that is the ammonium chloride we are using here. And complexing agent is ammonium citrate, and here we are using a sodium succinate, and temperature is almost same. So the chemical reactions are like anodic reaction, that is a sodium hypophosphite, or the hypophosphite is undergoing reaction, and from which electron is getting liberated, and that electron is being used to convert the metal ion to metal atom, and that is getting deposited. So this is overall reaction. So advantages, electrolysis nickel deposit are free from pores and possess better corrosion resistance than electroplated nickel deposit. So you please go through these advantages. And applications, it is used to plate on industrial components such as pumps and valves, shafts, gears and reaction vessels and other tools, etc. So this is what the electrolysis plating up of nickel. So any one of these two, either electrolysis plating up of copper or electrolysis plating up of nickel, will be asked in the examination. So you please practice the reactions properly. So this is the difference between, or the distinction between, electroplating and electrolysis plating, which normally been asked in several times in the examination, which carries around about 5 to 7 marks. Very simple. You have to remember the properties like a driving force. So in electroplating, of course, we are using a power supply, and in electrolysis plating, has I already told, it is autocatalytic redox reactions. So catalytical active must be of cathode, that is going to initiate the reaction. That's why the driving force with respect to electrolysis plating is autocatalytic redox reactions. So anode reaction is same, that is metal get converted to metal ion and electron, and here in electrolysis plating we are using a reducing agent. So as it is undergoing reaction, reducing agent is going to give oxidized products and electron, number of electron. And the cathode reaction is like same metal atom on both the sides, and site of anode reaction is separate anode, and here article to be plated. This is the site of anode reaction, because article to be plated means, as I already told, the cathode where we are going to have a deposition, that must be catalytical active. So that catalytical active surface is going to initiate the reaction, that is reduction reaction. That's why the site of anode reaction I have just listed here with respect to electrolysis plating is article to be plated, and site of cathode reaction article to be plated, and article to be plated with the catalytical active surface. Nature of deposit, since in electroplating pure metal or definite alloy we are going to observe, but in electrolysis plating, since we have used a lot of chemicals over there, so metal getting contaminated with oxidized or reduced species. And the throwing power is nothing but the evenly distribution of metal ion across the electrode is what we call, sorry, not metal ion, metal atom through the cathode is what we call it as throwing power. So you have to choose a bath which is having a good throwing power. So here throwing power in electroplating is not that satisfactory, but in electrolysis plating is good. And applications only on conductors. This electroplating is going to be done only on conductors, but whereas in electrolysis plating we can do on both the conductors as well as non-conductors. Even we can have an electrolysis plating on the glass. Only thing is that we have to make the glass surface with catalytical active just by treating it with the reagents. So this is the comparison between electroplating and electroplating and electrolysis plating. So this is also very important question. So this is the end of the metal finishing. Thank you.